Okay, I'm gonna pick up again. I'm still on page, well, I mean, you're probably watching these consecutively. I'm on page 209. And so we just graphed this. Took us a really long time. There were some, I had some learning curve to deal with. What I'm gonna do now is I'm gonna solve this problem. So same idea, do it a little quicker, I think, maybe a little less explaining, or maybe not, hard to say. So I got like a million wires that I'm dealing with, even though everything should have been wireless by now. All right, let's see. Let's use black, just in case you are going to print this. So I first need to graph 3 minus 3 cosine. All right, so I'm blowing this up. Then it like stop moving. All right, here we go. So it's going to be 3, going to be 6. I'm going to go to 2 pi, pi over 2. That's not pi over 2. What are you talking about? Undo that. Pi. And then pi over 2, 3 pi over 2. All right, so we got that. And then it's a negative cosine. So we're like here, 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 right? So there's 5 key points. And if I take those 5 key points and turn those into polar points, all I need to do is put a curve through them. And I know what the curve should basically look like. So it's going to work out. So let's just trace this so we can see. Okay, so I have that. I'm going to take these points, these non-polar, the rectangular points, right? So this is theta, and then this is r. So I'm going to take those and I'm going to put them over here on the polar curve, polar plane, polar grid. All right. So when theta is 0, and then I just have to like remember what I'm doing because I can't actually see that. Let me just scroll on this other computer. Okay, 3 minus 3. Okay, so when theta is 0, r is 0. So I'm going to start here. And then when theta is pi over 2, r is equal to 3 in this case. So I'm going to count by ones this time because that was a disaster. This will be 3. This will be 6. Okay, so by the time I get to pi over 2, I have to be at 3. And then by the time I get to pi, I have to be out at 6. So I'm going to plot this point. By the time I get to 3 pi over 2, I have to be back to 3. Plot this point. And then at 2 pi, I'm going to be back at 0. So this is cosine. So similar to sine, you have cosine of theta, and you want better points, like a better curve that just has like more shape to it. Use pi over 3 angles. But I'm usually not very concerned with that. I want to get the general shape right. And as long as I get that, I'm happy with it. So here we go. So, I mean, now I feel like I should do 2 pi over 3, but I'm not gonna. Let's just go for it. So we're gonna start here. So this is where it's 0, right? So I can dot in to kind of like give it some shape. But again, don't worry about that too much. Just kind of go, right? So like this, and then we're gonna increase until we get there. And now we're gonna just mirror that. So we're gonna go back in, and then boom. That part wasn't great. Can I undo that part? Yeah, I can. All right, keep going. Here we go. All right, I feel like that's a little bit better. And then we really want to keep track of what happened and when, right? So this point is 3 comma pi over 2. This point is 6 comma pi. This is going to be 3 comma 3 pi over 2. The most unnerving polar points, I think, are the ones that in rectangular would definitely give you negative whatever the coordinates are, right? Like you would expect this to be like 0, -3, but instead we're writing 3 comma 3 pi over 2. It just feels wrong until you get used to polar, and then it like makes sense. But anyway, this would be my graph. So what I'm going to do is move on to the next one. So the key points on the rectangular graph become the key points on the polar graph. And it's just like new graphs that you need to learn, right? Like at some point in your life, you didn't know what a quadratic looked like. You had to learn that. At some point, you didn't know what a line looked like. I mean, you knew, but you didn't know the equation and all. These are the same. So these are cardioids. You're always going to get the same 2 numbers. You could have a plus or a minus. you're always going to get just sine of theta or cosine of theta. So let's do this one. So it's going to blow up. Okay, it's going to take 2 pi. So pi over 2, 3 pi over 2. All right, and it's 8 minus 8 sine, so we're going to go 8, 16. 8 minus 8, so sine starts in the middle. It's a negative sign. It's going to be here, 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 here. And then fill it in. So, I mean, I guess in theory, you're watching this as a video, so you could speed it up, slow it down, skip it if you know what you're doing. So now I got to make a decision, right? So 16 doesn't fit on this grid, but just like in rectangular, I get to choose what the tick marks are. So I could go by, so I have 7, I could go by like 2, 3s. That's terrible though, because nothing works. I'm gonna go by 4s, count by 4s. All right, so, and then I'm just gonna label it as 8 and then 16, I think. Okay, so it's negative sign. So when theta equals 0, r is equal to 8. So we're going to have this. When theta is equal to pi over 2, r is already 0. And I feel like that's the last time I'll probably need to like zoom like that for this particular one. So we're going to fill in there. Then we're going to fill in when theta is equal to pi, we're at 8 again. And then when theta is equal to 3 pi over 2, we're out at 16. Push it down here. What did I count by? 4, 8, 12, 6. I did count by that. I feel like this is like smaller than I would like it to be. I'm not going to go back and change it, but could have done a better job. I wish this 8 and this point weren't like just right on top of each other. And then I know the general shape, right? So it's going to go kind of there and then come back out. And now we're going to swing out. So we're going to go from 8 all the way to 16 by the time we go from pi to 3 pi over 2. So like we're rotating this way and we're just going to like swing out. The biggest it's going to ever be is when you get to 3 pi over 2. And now we're just going to mirror it back. Like so. This is a terrible graph. So I could have plugged in its sine, so I could have plugged in 7 pi over 6 to get more form to it. But, you know, it's really the general idea that you're looking for. You try to do your best. I'm struggling on these. So let's label these up. So 8, 0. This is 0 pi over 2. So that's a weird one, right? The origin there. This is going to be 8 back at pi. And then this is going to be 16. 3 pi over 2. Okay, so not so bad. The graph itself, pretty bad. But let's go on to the next one. So it's those key points are staying key points. The rectangular key points are actually the same as the polar key points. And then one of the things I want you to think about is the sine graphs for cardioids are going to start on the positive x-axis. So you like immediately swing into the origin kind of for the negative one. For the positive one, you swing way up. So start thinking about that. That's like a really important thing because it lets you just graph them really quickly. And you don't want to think about it too much when you're doing these problems. All right, let's see. 5 plus 5 cosine. So I have an idea of what this is going to look like already. Like in my mind, I already know that 5 is going to be really important. 10 is going to be really important. It's going to be predominantly on the positive x-axis, and it's going to start like way out, right? Because cosine of 0 is 1, so it's going to start at 10, 1. 10 is the radius, and 10, 1, 10, 0, and 0 is the angle. So if we were in person, I would probably just graph this in the polar one to show you that like once you know what you're doing, you just like go for it. But I'm gonna do this instead because I don't know. I don't really know what you're doing right now. Hopefully you're watching this. Hopefully somebody's watching this. It's not no work. So, all right. So here, 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 when somebody tells you should learn how to graph trig functions, they mean it, because they just keep coming up. All right, got that. Theta equals 0, I'm going to be at 10. Then I'm going to go to 5. And I'm just going to be rotating counterclockwise. I'm going to go 10, 5, 0, back to 5, back to 10. So let's do that. What should I count by? All right, I'm going to like not overthink it, not try to give it more shape. I'm going to go with this is 10 out here. And I'm going to say that 1, 2, 3, this is 5. Okay. If you're going to try to substitute other numbers, right, it's cosine, so pi over 3 is a good choice. Don't do this weird labeling thing because it's just too annoying. All right, let me go a different color, right, spice it up. There we go. Then by the time I get to pi over 2, I'm going to be at 5. By the time I get to pi, I'm going to be at 0. You're at 0 because the cosine of pi is -1, and 5 minus 5 is 0. So it's always good to think about that. Unit circle still comes in handy. There's a point. And here we go. Whoa. Here we go. Whoa. This app, what am I using? I think Notability, I think is what I'm using. I'm not super used to it. Coming in. That's just not right. Here we go. Or maybe it was. I don't know. But I find this to be the hardest part for some reason. There. If I wanted more shape, I would have plugged in pi over 3, and I'm almost certainly wrong. There for the dimple. And then you just mirror it, right? So it took us pi to get half of this. That's going to be really important when you get to calculus, when you're trying to find the area of this thing. It's like, what values of theta do you need to consider? So for this, you'll need to consider all of from 0 to 2 pi, or, oh gosh, let me focus for a second, and then out. All right, I don't hate it. So from 0 to 2 pi, you get the entire thing. But like, look at that symmetry, right? From 0 to pi, you get half of it. So like maybe later in your life, it's better to just find half of it and double it, which is like a huge theme when you're dealing with polar. All right, what's the next thing? All right, I'm gonna stop this here because that was the last of these. Maybe I'll like zoom out so you can see. Whoa. Okay, and then, you know, like, let me just do this for 1 second. What color would be good? This one. Okay. This point right here is this point. This point right here corresponds to this point. Corresponds to this. Corresponds to this. And then this one also will correspond to this. So if you weren't watching when I did that, none of that makes any sense. If you're just like jumping in. But if you rewind and look at it, you can see I like circled them and pointed them out in order. All right, hope this was helpful, and I'll be back with more if I can figure out how to turn this off. That's like my #1 like problem right now is I can't figure out how to stop a video. Go do it. Here we go.